Hello guys, welcome to my channel and let me introduce myself first. So my name is Arnav Goel and I am from Taparati Sonipat in third year doing BTech in CSE. So without any much further delays, let's start with the problem. So the problem is from codeforces, that is Alyona and a narrow fridge. So Alyona has recently bought a miniature fridge that can be represented as a matrix with H rows and two columns. Initially, there is only one shelf at the bottom of the fridge, but Alyona can store arbitrary numbers of shelves inside the fridge between any two rows. A shelf is two cells wide, doesn't occupy any space, but separate the inside of the fridge to the lower and upper part. So the image is provided by the question, and Alyona has n bottles of milk that she wants to put in the fridge. The height bottle is AI cell store. Let's suppose if it's 5, then its height will be 5 and one cell wide. She can put a bottle on shelf if the corresponding space of the shelf is at least as tall as this bottle. She cannot put the on the top of the another bottle if there is no shelf between them. Two bottles cannot share a shelf. Alyona is instructed that that is the largest K that can we get to put the bottles from 1 to K in the fridge at the same time. Find this largest K. So I will explain the question. I have read this first, and then I will explain the question when in the whiteboard. So here's the input that is n and h that is given. Important to be noticed that n is from 1 to 10 into 10 to the power 3, and h is a 10 to the power 9, that is maximum. That is the number of bottles and height of the fridge. So a1 to an is the second line, that is the element that is given so far, that is the height of the bottles. So we have to print out the maximum integer, that is k, that is how many bottles that can we put so far. So that is 1 to k in the same time. So okay, so wait a second. Then let us move to the this. So yeah, first of all, let me thank you that our channel has closed 500 plus views. I know it's uh like how can I tell you? For me, it's a massive thing. So yeah, thank you for like 500 plus views. I've closed my channel and I couldn't think so far that I can do this too. So yeah, thank you all. So let's move to the question. So first of all, let me explain the question that we have some shelf. Okay, so we have some fridge. So we have we have some bottles. That is, we have some bottles. That is A1 to AN, and we have to from the starting point and then up to kth point. That is the prefix you can say. So P of K that we can name it as. So from A1 to AK bottles that we have to put in this refrigerator. Okay. So but it will be like let us suppose here we put A1. Okay. So here will be the shelf. Then we will put A2. It can be we can just do like A2 can be put at here or A2 can be put at here. It depends on us. Like since the bottle width is one and total width of the page is two. So that's the thing. So so if we put A2 at here and A1 at here, the maximum of both of them, then we will put the shelf at here. Wait. Then we will put the shelf at here. Then let us suppose we put A3 and here A4. So the shelf will become at here. Then the maximum of both on them, let us suppose it's A3. That is the A3 that will be put so far. So this is the question saying. So we have to find out the maximum value of the K, that how much bottles that can be put from 1 to K. Okay. So I hope that you got the explanation, that you understand what the question is saying. So there are three approaches. Uh, Two approaches has been done by me, and one of the approaches are so from that two approaches, one of the approaches also we can be seen in editorial, and one of the approach is like optimized, too much optimized, and I have to see like how can we do this. So first of all, let comes to the brute force part. So like brute force part, you can just wait. So there is one brute force part that solved in order of n square logarithmic of n. Yeah, I think yeah, that's true. And the optimized one is order of n log. square n, and too much optimized that I have to see to that is order of n log n. So first of all, let's proceed with brute force part. Okay. So before proceeding with the brute force part, uh, like like how things will happen. Okay, like how things will proceed out. So we have some A1, we have some A2, we have some A3, and up to AN. Okay. So let us suppose we have chosen from A1 to A5. We have to choose from A1 to A5, and here is our refrigerator. So first of all, we will try to put A1, then we have put A1. Okay, so let us suppose A1 is being put, and this is the thread. And A1, then we will go to A1 to A2. Then, of course, we find out that if A1 is greater than A2, then we will, our brute force method or our greedy method will say, okay, put A2 at here, and this one is the maximum height so far. So here we put shell. Then A3 comes. If A3 comes, and let us suppose that A3 is maximum than A1 and it is maximum than A2. This is a situation. Then how can we put things that comes in our mind, like we can do it is like put A1 and A2. This is the minimum height that we can approach, that we can get, and then put A3. That is the first thought I have also think like that. Like put the minimum, then sorted way that is A1, then A2, then A3. But it is not so. Like uh, there is an input case for this to be proved wrong. That is the first input case, I think. So 2, 3, and then 5. We put 2, then we put 3, and then if we put 5. So, like, if we do this, like, if we do the this way, like in the sorted way. So, we put 2, then we put 3, and then here we will put 5. So, total height would be 8. And maximum that the height of the fridge is 7. So, we can't go with that. But we can go with like 5, 3, and then 2. So this is because I will explain. Like yeah. So why this is happening? Like why this works and why not this works? Like in the sorted way, it looks so much better. Like it's looks so much clean and like better to go with. But it's not work at all. Since it can be said that we know that if we sort an array, if we try to sort an array. So here 2, 3, and then 5. We have to put these three borders at all. Okay. So we have to put. So like we tried like if we try to put the maximum, then we will put the maximum first at here. Wait a second. So what I was telling you, like we need to put these three buttons at all. Okay. And these three buttons. So like in the sorted way that is 2, 3, 5 doesn't work at all. But we know that like 5, 3, 2 works. So this is because that the total height, that is the total height will be 7. This is like what you will think. That is uh, here. Let's suppose maximum 1, then maximum 2, then maximum 3. These three have to be put also too. So how can we put, like we will put maximum 3 at here, and then we will put maximum 1 at here, or maximum 1 at here, and their total size will be lesser than if we think with maximum 2 and maximum 3. Do you get it? What I wanted to say? Like what I wanted to say, let's say this is 2, this is 3, and this is 5. We know that 5 plus 3 would be 8, and 5 plus 2 is 7. That is the minimum, and this is the minimum that we can take out. So that's why we will choose like uh, put the maximums here. Let's say maximum 3, and let I will select maximum k and maximum k minus 1, since all these bottles have to be put in the refrigerator. So that's why we are doing like this way. Then maximum of k minus 1. Then maximum of k minus 2 has to be put at all. So maximum of k minus 2. and maximum of k minus 3. Like this way, we have to put at all. Up to here, maybe maximum of 1 comes here or maximum 1 of comes here at here. Depends on this. So we are chasing about this part. We wanted to find out like if we have chosen k, then we didn't choose the previous part. That is k minus 1 we will not choose because we at k is the height of the shelf and k minus 1 will be fit at all. So we choose k, then we choose k minus 2, then we can choose k minus 4 like that. So this is the way we will approach this problem. So since the brute force way that we can think is to iterate all over the n. That is I equal to 0, and then I equal to 1, then I equal to 2, and then I equal to up to n. And for this, we will sort this part, and then we will sort this part, we will sort this part. That is, it will post us around order of n, this will post us around order of n log n total. So total cost will be order of n square logarithmic of n. And this would be lesser than to get TLE. Like if n is 10 to the power 3, that is 10 to the power 6, log 10 to the power 3. Uh, so it would be lesser than like it would be in the safe limit. We will not get TLE. It is less than 10 to the power 8. So we will can approach this way. So after like let us suppose at I equal to 3, we have sorted things and then we will do is what? Is to move from the maximum one, that is choose this one, that is I equal to 3, then I equal to 1, and that's we will choose these two heights and we will check them. Like the height that we have chosen, is it less than the k or no? That is the total height. So the total height that is this less than or not? Equal to. So if this, then we will proceed our I, that is we will iterate. As if this not go like the way that we cannot put more motors with that height if we choose. So we'll answer our the previous value that is I minus 1 and we will return. So this is the way that we can go through with order of n square of logarithmic of n. Wait a second. Here is the question. Is this one? Is yeah. So let us move to the code part then. So what we are doing, we have just taken 10 and h, that is the inputs, and v of I, v of a vector we have taken, and then from I equal to 0 to I equal to n, we are moving, and then we are sorting up the things. Then we will calculate the height, that is calculate for into j equal to I, j should be greater than equal to 0, j minus equal to 2. So calculate plus equal to v of j that we have chosen, and if we find out anything that is not fulfilling our conditions, then we will just see out I and then return. Else we will see out, and since we can proceed all the way. So this works in order of n square logarithmic of n. But can we optimize? Yes, we can optimize it too. But how? Like I have already told you that we can optimize order of n log square of n. So how can we optimize? So the optimization works like uh, since we know that from 0 to n we have to find out which k is gives the best optimal value. So let us suppose this k gives us the best possible value, but k plus 1 didn't gives at all. So if we choose the k plus 1 total. So but we from here what we can get in think like what we can think so far. If k works, if k plus 1 doesn't work, then k plus 2 n doesn't work at all. But k minus 1, k minus 1 up to 0, they all work. So did you get something from here? Like this way, like the diagram that I've presented here. Yes, this is the binary search that we will use. Rather than iterating from order of and that we are doing like for each and every we were checking. What we will do is to use the binary search on iterating part, that is n. That is where we will use at here. Here we will use the binary search, that is the binary search algorithm, that is the mid part we will check, and then we will sort the mid up to mid part. And then we will calculate is this works or not. If this the following works, then we will store the answer and then we will move to the right. If this doesn't work, we will move to the left. So this works in order of n log square n. But the editorial Also optimized, also saying to be optimized, we can do this problem in order of n log n. I try, but I didn't get how can we do this, and I tried to use ChatGPT too and many things research, but I didn't get at all. So if you know that can how can we do this in order of n log n, so put that in comment that how can we do, and if you have any queries or any problem regarding what I have explained or anything related to the question, so feel free to post in the comment and I will be here to explain. So that's from my side. Bye.